I will short very much the introduction, and then we leave space for the discussion afterwards. Just introducing me, I'm Michele Bonino, the head of Department of Architecture and Design here at the Politecnico. So my field is very far from the topic of today, but I'm also coordinating the Politecnico China Center, and so my links to China make me very interested with the topic of today. I would like to welcome Thomas Mullaney, that is the first time at the Biennale Tecnologia, and also Alessandro Areso, that is a long friend of Biennale Tecnologia. You did as a speaker all the editions of the Biennale. Just a few words about our guest today. Thomas Mullaney is the professor of Chinese history at Stanford University. He got a very prestigious Guggenheim Fellowship, and among the many publications he did, there are two books that are very interesting for us today. The first one in 2017 about the Chinese typewriter, so la macchina da scrivere, how Chinese invented a way to write thousands of characters through a typewriter. And then recently, so actually, as Alessandro said, still to be published, so it's a kind of first presentation in Italy, the book, The Chinese Computer, A Global History of the Information Age, to be published by MIT Press in few weeks. At the same time, I already introduced also Alessandro Areso. We will make a dialogue with Tom after his presentation. He's an expert of international affairs and public policies, a scientific advisor of the magazine Limes, and also advisor of the presidency of the Council of Ministers of Italy. And among his book, I want to mention for La nave di Teseo, a quite recent book, a couple of years ago, Le potenze del capitalismo politico, Stati Uniti e Cina. But I leave straight the floor to Thomas Mullaney, thanking you again for being with us at the Biennale Tecnologia. Grazie.
Grazie. Thank you. It's a great honor to be with you, and as was just discussed, the new book, The Chinese Computer, is coming out in a few weeks, and this is my first opportunity in Italia to speak on this. I have family connections. My wife's family is from Venezia, so we spend quite a lot of time there, and I wish I could be there in person if other obligations didn't prevent. I want to speak very briefly about the overarching argument of not just the Chinese computer, but also the Chinese typewriter. And in essence, I want to present what are, in effect, the 5 main arguments of both of these books. I will say these arguments can be summarized very simply, but my hope is the subtleties and complexities come out in the discussion. The first and most basic argument of the book is that Chinese writing is not a problem intrinsically. Rather, Chinese writing and many other non-Western writings become a technological problem due to the specific relationship between information technology, Western-dominated information technology from the mid-19th century to the present, and the specific particularities of certain writing systems, Chinese, Japanese, Korean, Arabic, Devanagari, Burmese, and the list goes on. But this relationship between non-Western writing systems and an information structure that was built specifically for the Latin alphabet. For English, yes, but for the Latin alphabet above all. The second argument that I make over the course of these books is that the puzzle of Chinese, the problem of Chinese, begins with electric telegraphy, with Morse code. Prior to electric telegraphy, Chinese was not a problem. We have woodblock prints, xylography. We have early modern visitors to China, Japan, from the West who are amazed that you can purchase a book in Edo, Japan, or in, say, Ming, China, for the same price as buying a bowl of noodle soup at a time when in Western Europe, the book was quite an expensive commodity. It only becomes a problem and a puzzle from, say, Morse code onward. But once it becomes a puzzle, it becomes a global puzzle. It becomes something that is fascinating for engineers, linguists, entrepreneurs, amateurs all around the world. So the Chinese in Chinese computer and the Chinese typewriter is not the ethnic group of Chinese or the nation state Chinese. It really is this puzzle of modern Chinese information technology. How do you take a writing system that is not alphabetic, with tens of thousands of characters, and then fit them inside a logic that was not built for it? The logic of Morse code, the logic of the typewriter keyboard, the logic of the personal computer, but also the logic of graphics, of printers, of optical character recognition. All of these logics that were developed by English-speaking engineers primarily, that then sort of spread around the globe. And so in both books, Chinese typewriter and Chinese computer, there are Russians and Taiwanese and Italians and Germans and Japanese and Koreans. And there's all of these companies and engineers that are just fascinated by this engineering puzzle. The third argument is that something happens along the way in this writing, so in this book. And the simplest way to say it is that in my first book, The Chinese Typewriter, the story is failure, 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 moderate success, tiny bit of success, failure, failure, failure. Then the timeline of the Chinese computer is failure, 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 stunning global success. Stunning global success. And what's amazing here is just to of this is an image from a Chinese computer typing competition in the year 2013 in China. I won't show you the video presentation, but this is an example of one of the computer screens of one of the contestants. The important thing is that the person who wins this competition will win this at a speed of 221 Chinese characters per minute, or 3.7 Chinese characters every single second. And since Chinese characters and English words or Italian words are not quite the same thing, that translates into a speed that is faster than any recorded typing speed in the entire Latin alphabetic world. So how is it that Chinese telegraphy was much slower than English and Latin alphabetic telegraphy? Chinese typewriting was far slower than English language typewriting. Early Chinese computing was also far slower of a human-computer interaction. But then suddenly, by the time of the 2000s and 2010s and the present, there has been a massive inversion between these two speeds. And that's what I explain over the course of the book. I would love to discuss. And then fourth and finally, and then I immediately would love to start discussing this, is that the way that the average computer user globally uses their computer is in the year 2024 far more similar to the way that a Chinese computer user uses a computer than it is to anyone in Torino or New York or San Francisco. So the model that I argue, this new era in computing and electronic writing, is not limited to China. It is now, in fact, the new global norm for how it is that one can interact with a Western-built machine, but produce non-Western scriptural and orthographic results. And so by studying China, we actually learn about the fate and future of electronic writing in the 21st and perhaps 22nd centuries and onward. I'll close with a very basic statement, which is when ChatGPT came out last year, so much news about it, the Latin alphabetic English-speaking human computing world was shocked. What a strange way to interact with a computer, where you provide a code, a prompt to the machine, and then the machine performs these operations and produces text. For me as an historian of Chinese computing, it wasn't shocking at all. It was a very natural next step in a progression of human-computer interaction that, in the case of Chinese computing, goes all the way back to the very first Chinese computer in, say, 1959. Let me just show you what a Chinese computer looks like, and then I will immediately, here you have a Chinese typewriter. This is a typewriter that has no keyboard. There's no tastiera, there's just an index typewriter. And I also want to make sure that I show you at least what the first Chinese computer will look like before we dive in. This is an incredibly interesting machine from the early 40s. This is the IBM electro-automatic Chinese typewriter, kind of a forerunner of Chinese computing just a few years later. I had a chance to interview the son of the main inventor and the main demonstrator here, Lois Liu. And then very importantly, here we have the very first properly Chinese computer built at MIT by an engineer, a professor of electrical engineering, who did not speak a word of Chinese, but was thinking through the puzzle of developing a system that had the capability of producing Chinese. So these are the four arguments. The global information architecture has been dominated from the 19th century by the Latin alphabetic world. This placed a vast number of writing systems, Chinese most importantly, at a huge disadvantage to these technologies of electric telegraphy, typewriting, and so forth. It threw the world, the non-Western world, into a condition of almost a techno-linguistic crisis of trying to figure out how to speed up, accelerate the process. And out of this long period of crisis and failure and modest success, some profound transformations in understandings of both writing and technology emerged, to the point where in the 21st century, there has been an inversion where, technically speaking, the fastest human-computer interaction language in use today is Chinese, not English or French or Italian or any Latin alphabetic writing system. So I'll go ahead and stop sharing, and I look forward to diving into the details of this through our discussion.
Thank you very much, Thomas. I think we have time first to have a short interaction, the three of us. So I will leave the floor to Alessandro soon. And then I already asked the audience to prepare. You will be free to do questions, both in English or in Italian. Sarà anche possibile per chi preferisce fare domande in italiano che saranno tradotte in inglese per Thomas Mullaney dalle nostre traduttrici. Quindi entrambe le lingue benissimo. Maybe I leave the floor to Alessandro for a first round of comments or questions to Thomas. Then I will have one on my side, and then we leave the floor to you, the audience.
Yeah, thank you, Michele. I think it's great to be here. I think it was a very brilliant idea by Juan Carlos and the others of Biennale Tecnologia to allow us to be introduced to this book. I think to this really significant historical work. If you put the two books together, it's a feat of scholarship very worthy of consideration. And I hope that also the book would be translated into Italian. There are several interesting stories inside the book, and as Thomas said, it's the Chinese language is sometimes in the book a kind of prism and kaleidoscope of problems. For instance, I remember about this electrical engineer who is relevant in the book, Samuel Caldwell, if I'm not mistaken. He wasn't fluent in Chinese at all when he introduced something that is very important for this reasoning. Just probably to allow the audience to let Thomas delve more in some concepts of the book. One that was introduced in relationship also to ChatGPT and what we are discussing now about prompts and what we want from machines, which is an idea of input and output of text, but mediated through a text which is not a direct part of the output that we have. And then he introduced, and this applies to these two, but also to the overall reasoning of the book, this concept of hypography, I think is the right term. And maybe having him to explain this, I think it would be interesting for the audience. And then another comment I wanted to make, this is in the conclusions of the book, I think, and he reminds us that this idea, there's this idea of a challenge of to China from basically a modernity dominated by the West. And in a way, even if we go through the timeline of the mid-19th century until now, this relates with the overall Chinese idea of the so-called century of humiliation and a period where a civilization, to be more precise, which even in its linguistic imagination considers itself as a cornerstone or a crucial part of the world, feels that for the developments of colonial European powers as well as Japan is taken on a periphery of history, and then rising up through new history of the People's Republic of China, and also the age of reform and opening, leading up to now, to also developments both in the Chinese economy and the industry, as well as the Chinese political position. And now we are also, Thomas reminds us in our book, in an age where not only China is a key part for making the things that we are discussing, given that it's a key center for electronics, as well as producing those laptops where we type in. But also there is this very large share of global internet users who are Chinese, and therefore this production of text, even the specific production that he discussed called IME is far larger than what we have in the Western world. And so I wanted to ask also about the self-perception in his idea of present China, of this problem. And then we can leave, after a brief comments by Thomas, I think we can give to the floor to have questions by the audience.
Thank you. Yes, I appreciate that. This is a very big issue. I can actually, it probably is useful, I think, for the average, say, Italian-speaking or English-speaking computer-using world. It's not second nature how Chinese computing works. Let me just say, every computer, every desktop across the Chinese-speaking world is a QWERTY keyboard, every single one of them. And that raises the question, how does that work? This is maybe where I will show this one particular image, if I could. So this is, for example, let me go into full screen here so you can see this. This is an actual screencast of the computer screen of the person who won that competition in 2013. And what's important, the text at the top, the Chinese characters at the top, those are the characters that every person is trying to copy. You know, that's the text. On the bottom, you will actually see two spaces for text. One is the composition window, where this man is actually copying it. But then you'll notice this little pop-up menu on the bottom. Just watch it in action, and then I'll explain, you know, what is going on with this. Excuse me. What you'll see there is what this man is actually typing on his keyboard is DDIP, FTJG, DXA, E, LH, WP, PE, YMH. And as he's entering these Latin alphabetic letters, the pop-up menu of this program called an input method editor is intercepting every single one of his inputs and trying to calculate and figure out which Chinese character, or maybe even 2 or 3 or 4 Chinese characters he wants. And that's what those little suggestions are on that bottom line. What this means is that all Chinese computer users have this cybernetic feedback loop where what you type is never what you get. So you type all of these Latin letters, there is this cybernetic feedback loop from the input method editor, and that's giving you options. Do you want this character? Do you want this character? And only after you select one of those characters is it added to the screen. So the simple answer to this term hypography, which I try to argue for, taking every single computer user, let's imagine that there is a billion Chinese computer users, internet users that are working as we speak in this world. What that means is that we have a situation in which every single day, every single week, every single month, this immense transcript of Latin letters and Roman numerals are being produced. People are sitting at the QWERTY keyboard or maybe on their smartphone and producing this immense corpus of Latin letters and Arabic numerals. That entire corpus of quadrillions of letters, I've calculated that a year of this is larger than all of the books in the Library of Congress in the United States, is immediately destroyed. It's ephemeral because the primary transcript of writing in Chinese electronic writing is disposable. It is meant to be, it's purely an input that is meant to be fed to a computer program where the computer program is trying to perform further operations on that input in order to get you the output you want. Input does not equal output. In Western computing, brilliant engineers tried to create the special effect where input equals output. I type the letter W on my keyboard, the letter W appears. I write the dog bit the cat, and it appears magically on the screen, and it produces a feeling in me that input is output. They are the same thing. In Chinese computing, from the very beginning, input was never output, could never be output. There was always an understanding that these two things are completely separate. And that's why I make this point that ChatGPT looks very strange if you're talking to an audience who believes input equals output. Wait, now I have to separate the two? But it looks less astonishing, less new in many ways when you're talking to not just Chinese computer users, Japanese, Korean, and again, many non-Western computer users, communities for whom input has never been equal to output from the beginning of the computing age. And so there's something, in a sort of sense, ChatGPT just brings us back to our roots, because in the digital environment, technically speaking, input never equals output. It's all electrical signals and zeros and ones and mediation. But the Western world has been sleepwalking through a dream that input and output are the same, because this special effect was produced by people like, Wozniak and Jobs and IBM and others. But it was always a dream. It has been a dream this entire time. Input has never equaled output. And half of the world is prepared for that reminder, and half of the world is shocked by that reminder. I'll pause there. Maybe the second question I can fold into any questions from the audience. And devo dire che posso capire le domande in italiano, ma quando parlo come un bambino di 3 anni. So I'll answer in English, but I can listen in Italian in case that's helpful.
Thank you. I had a question on my side. You said, I was interested when you said failure, big success, about the challenge of making a keyboard of some dozen of characters able to interpret 10,000 Chinese characters. So this change was some way disruptive, was a very abrupt change. And so I guess this was a shock for the handwriting of Chinese language, because we know the Chinese calligraphy is almost an art. Kids spend hours and hours trying to write manually every character. So I ask you what happened when this big success was created, because I guess there was a big change in the relation with the handwritten Chinese language.
Right. The invention and the success of the input method editor, this in Chinese, the 输入法, this idea of the input method or the input system, this ability to use a QWERTY keyboard to produce a Chinese text output completely changes the instruments of writing. And of course, the instruments of writing have been changing since the beginning of time. Cuneiform and epigraphy and xylography and typography and xerography. So that's part of this. But what we've moved into, hypography, which is I'm trying to make the argument that we have entered a new age of writing. We are in the incunabula of this age, very similar to the incunabula of the Gutenberg era. We're in the first 50 years of an entirely different mode of interacting with writing, in this case through electronic mediation. But it is very true that this form, when you sit down at a computer and you input Chinese, what you are actually doing, you are not typing Chinese. You are not writing Chinese. You are not composing Chinese. You are finding Chinese. You are searching for Chinese. So 输入法 or input, another way to call it is retrieval writing or search writing. What you are actually writing on the keyboard is not meant to go on the screen. It is meant to help a program find the characters you want from memory in more and more and more and more sophisticated and efficient ways. So the whole model, it's the difference between the cat bit the dog, where you actually need to spell out THE space C, DOG space BIT space. In this case, what we're doing is we're saying to the computer, here are the criteria. Please go find me the words the cat bit the dog. Find it faster than I could even find it if I typed it entirely out. So after 10 years, 20 years, 30 years of living in this kind of writing environment, it is true that if you hand a pen or a calligraphy brush to, in some cases, a PhD in, or a very prominent, very literate, very educated person, they may not be able to remember how to write that character with a pen. But are they illiterate? No, of course not. Are they non-literate? No. It's that they are living in the context of a shifting instrumentation and mediation of writing. I suppose that after the Zhou dynasty, if we go into the Tang and the Song and the Ming and the, if you handed a Ming dynasty literati a bronze and a burin and said, carve the Chinese characters on this bronze, he probably would have been really bad at it, because this mode of instrumentation, this mode of writing, had long since been replaced by the brush, for example. And so I think now what we're seeing is, of course, a decline in penmanship. It's a very, many people in China talk about this so-called to lift the brush and forget the character, 提笔忘字, to lift the character but forget how to write the brush, is happening. But that's not because people are forgetting Chinese, but because Chinese itself is now webbed in a different instrumentation of writing. And so we don't have the words for this new era. And that's why I don't like inventing words, but that's why I felt the need to invent the word hypography, to try to give a name to this strange new era we're in, so that we could understand what this era is, in fact.
Grazie mille. Lasciamo a loro.
Sì, prego.
Domande, questions? Okay.
Oh, please, over there. There are
at least 3, 4. Okay, great.
Sì. Buonasera. Negli anni '80 lavoravo in Olivetti sui computer giapponesi che avevano la tastiera giapponese con un generatore di 3000 ideogrammi. Allora ipotizzai che sarebbe stata necessaria una riforma il cinese aveva 70.000 ideogrammi, il giapponese 30.000, sarebbe stata necessaria nei successivi 20 anni per la digitalizzazione. Ecco, questo è avvenuto, è un'ipotesi che ho fatto io ed è caduta. Grazie.
Ok, prendiamo l'altra domanda, forse.
Excellent. Grazie. So I get to work in Ivrea at the Archivio Storico di Olivetti, one of the greatest moments in my career many years ago. Should I proceed?
Yeah. We were picking another questions too, but please.
Oh yes, so pardon. I will wait. No, I will wait. I would love to hear a second question. I will wait.
No. Please go ahead.
Oh, thank you, Professor Mullaney. One of the things that I find it very interesting in this topic is like the standards that we have and how we moved into having more characters other than Latin characters, as was evident in moving from ASCII to Unicode. Are we going to need another standard for a set of characters that we might need from a language like Chinese or maybe Japanese? And if so, how complex is the question? Meaning complex in terms of computational complexity and the challenges that a computer scientist might face in building a system that can aptly provide some tools to deal with this challenge. Thank you.
Please, Thomas, go ahead with the answer.
Wonderfully, yes. I love the first question and the second as well. I can't resist just showing you another image, if I may, because I find it hard to understand things without visual prompts. But so, for example, the Hanka, the Chinese character generator card, was a huge innovation in the late 70s and early 80s with many, outfits, including obviously we heard from our audience member at Olivetti. And what's fascinating about this, there are many things that are fascinating about this. I mean, some refer to this as the Chinese on a chip card. So we have, Hanka or Zhongwenka or Hanzi, 字模发生器 or Chinese on a chip, which is my favorite. Most of these had about 3,000 or 4,000 or 5,000, somewhere in that order. And that number is an incredibly interesting number, because that number is in fact roughly the exact same number as the number of characters on a Chinese typewriter. This is to say, one strategy for how to solve the puzzle of Chinese dates back all the way, in fact, to telegraphy and typewriting, which goes basically, we solve this puzzle. How do you fit 100,000 characters onto them? The answer is you don't. The answer is you undertake a large-scale statistical analysis of the Chinese language, newspapers, novels, journals, children's textbooks, and you try to determine which are the, say, 3,000 or 4,000 characters, 5,000 characters that are absolutely necessary for everyday usage. And then you effectively banish the rest of the writing system from whatever the technology is. And so this number of 3,000 goes back really far in the story. But one of the other things that I love about it, and I can't resist showing, is that there's even a deeper strategy, which the Hanka, the Chinese character generator cards, use, that dates back all the way to Chinese movable type. As many of you may know, Gutenberg does not invent movable type. Movable type was invented in China, but then very rapidly abandoned because woodblock print was far more efficient. But when it comes back later, there was a technique in the Chinese printing office which is very simple, is that, okay, we have 70, 80,000 characters in this very large space, but most of them are very infrequent. Just like in the English language, I and you and me is much more frequent than, say, avocado or alligator. And so they developed a system of shaping the whole room of the printing office according to frequency, to make sure that Chinese characters that were more frequent were closer to the print bed, and those that were less frequent to the. That idea actually baked into, was adopted and borrowed by Chinese developers and engineers at Olivetti and elsewhere in the 70s and 80s, which was that more common Chinese characters would be loaded into computer RAM, with basically infrequent characters being offloaded, sometimes into hard drives or into hardware, because we want the frequent characters to be able to be produced in 0.1 seconds. And it's okay if the infrequent characters require a second, as much as a second, to retrieve from memory. So there are some very old strategies that date back to the 19th century that show up again and again, even in the 70s and 80s. And 90s and onward. I just love to. When I first realized, the relationship there, it really made me quite excited. On the question of developing next level systems, this is a very difficult question. So I gave the example of Chinese input that is now far faster than any recorded typewriting or computing speed that has been achieved in English, okay? So one might think that the story is over, that now we have global informational equality, or maybe this is a moment of Chinese victory in the story. The Latin alphabet is still dominant. We are still operating fully within a Latin alphabetic dominated information infrastructure. It's simply that many different parties, Chinese writing being a major part of these, has built these interior, almost subspheres inside this large sphere of Latin alphabetic hegemony. There are sort of these nested spheres that are operating inside of this hegemony. And so there is a big question as to whether or not it is even conceivable to move from the architecture that we have today to an architecture of computing that is in fact universal or agnostic to writing. I'll give you a very simple example. There has never been a serious programming language in Chinese. All programming languages basically have to be resolved down to the ASCII character set. And the second example I would give, there is no bank password or website password that is in any character set except the ASCII character set. Whether you are in Egypt or Cairo or Mexico City or New York or Torino, your password is in ASCII. And that's because at the deep levels of the architecture that has been built since the 19th century, it is still wedded to the Latin alphabet. It has just been stretched around the world.
Excellent. Other questions, please? Over there. Wait for the mic. Just. Go ahead.
Forgive for my very naive question, but we are not talking of the relatively old system of inputting pinyin.
A great question. Should we take one more, or
no? Please answer.
Sure. So, if anyone is unfamiliar, pinyin is is short for Hanyu Pinyin, which is the official Romanization system of the People's Republic of China. It is the reason that Beijing is no longer Peking, P-E-K-I-N-G, but B-E-I-J-I-N-G. Beijing, B-E-I-J-N-G, is Hanyu Pinyin Romanization. Peking is this older Romanization known as Wade Giles in some variation. And so we have this system. It was promulgated by the People's Republic of Chinese government in 1958, but then the Cultural Revolution slowed down its popularization, but it made a comeback in the 70s and 80s. Interestingly, if you were to meet any engineer working on Chinese computing in the 50s, 60s, 70s, and most of the 80s, they would think that pinyin input, that is input using a QWERTY keyboard, where you are trying to describe the sound of Chinese characters, a phonetic input, was the worst possibility in existence. It was the worst option of all potential options. And so for the first 4 decades of Chinese computing, people were still using input, but they were using letters and Arabic numerals in order to describe the shape of Chinese characters, the structure. These are called structure-based input systems. So this is literally, what are the shapes and size of the character? What strokes are in it? What are the structural properties of the character? And then using Latin letters to describe that according to some code. So in the 50s, the 60s, the 70s, the 80s, and even into the 90s, structure-based input is dominant. Pinyin or phonetic input is dominant today. If you were to look at someone in a Shanghai Starbucks, chances are they will use one or another pinyin input. When does that start? It starts in the 90s, very, very, very late in the game. And the reason finally pinyin input becomes competitive in the larger set of strategies is because of predictive text and what we now think of as en route to AI. Predictive text, computational, sort of distributed large language models and so on. There's actually a predecessor history. Before we get large language models, there were many, many little language models that were all over the story of Chinese computing. But until that moment, until we get to that place of very sophisticated predictive text engines, everyone said phonetics is the worst. Why? Well, for one thing, there's very little control. You have lots of, well, I'll give you one example. One reason that was a big is, let's say I give you the Li, Li. How many Chinese characters have the pronunciation Li? No tone markers in this case. It's over 70. There are over 70 Chinese characters that have that phonetic value in Pinyin. And so it's a disaster computationally to try to disambiguate that stuff. So for the beginning part of this, from the 50s through late 80s, early 90s, the main approach to Chinese input is one or another structure-based input system.
Thank you. A few other questions? Altre domande? Oh, ok. Ne abbiamo due, una lì in mezzo e una qui.
Io aspetto.
Thank you. I'm Chinese, and I never thought about this. This is the first time I ever think about the input system invented by Chinese so powerful, because I never used it, because Ubi, for me, is for my parents' generation. I use Pinyin. And what you mentioned is true, because when I use Pinyin, because I study foreign languages, the problem is true when I type in the Pinyin, there are so many suggestions. The problem is now if I have to write the Chinese character in paper, I don't know how to write it. I have to check my phone, I write it in Pinyin and check which one is correct. So I don't know, it's very, very interesting, your argument, your book, but I don't know what is the meaning? Because if the younger generations, they are not using the system, what is the point? Why is it important to talk about it? Because it is information infrastructure is dominated by the Western programming language, and for us non-Western languages, there is what is the meaning of talking about the Chinese system? And that's it. Thank you.
Abbiamo un'altra domanda qui sotto.
Hi, the question that I have is that like many of the things that we debate are coming from the characteristics of Chinese language. And do you think that we can apply the brilliant idea that they have for typing system to improve the way that we are typing right now, or not?
I love that question.
And I'd add just one final reflection. I mean, in a way, your story is a story of a relative say, revenge of Chinese from that periphery of its subsphere of Latin Western hegemony, but it's significant. What are your thoughts on? I mean, there are many other languages and cultures which are marginalized and at the risk of disappearing in that environment. Any thoughts on where they could stand and find ways to survive if they don't have the significant demographic or political weight of the Chinese system? Over to you.
Thank you. Thank you. This is your question and the first question just now are connected. That this is still alive and well as we are speaking today. So why study this? I think there are many ways to answer that question. I'll just give one that connects. The Unicode Consortium, by their own categorization, has identified that out of all the world's living languages, let's just say 5,000 living languages, that something in the order of 97% of them or thereabouts is considered digitally disadvantaged. That is unable to fully partake in digitally mediated writing for one reason or another. It could be something as fundamental as there is no character encoding for it, which is just death on arrival. There is no keyboard for it. There is no way to render the graphics, the script properly on screen. There are very few, if any, digital fonts. A panoply of there are no large language model. There are no corpora for a large language model. So the story of Chinese is the story of really the first major digitally disadvantaged language, and how it in a sense it overcame this disadvantage without in fact ever transforming the structure that produced the disadvantage in the first place. And so that's also a kind of paradox of the story. So there is a lot to be learned by the Chinese case when it comes to thinking about literally thousands of other languages on Earth that are in various stages of digital disadvantage, according to the Unicode Consortium. We have started a new initiative, a Stanford presidential initiative that I'm directing right now with some colleagues. It's called Silicon, and it is focused entirely on trying to advance digitally disadvantaged languages from all around the world. I'll give you, Chinese is an interesting case because you're right, the Chinese had the market behind it. People wanted to solve this because of the geopolitical importance of Chinese, the economic importance of Chinese. But who is coming for, I could probably list a number of languages that many in the room have never heard of, that have no market, and therefore who really is concerned in these cases? And the answer in many cases is really the script community themselves and few others. And so this is a widespread problem that is becoming only more acute with this new wave of generative AI. Because generative AI is going to produce an even greater schism between advantaged and disadvantaged writing systems in the digital age. So I do think that one reason to study the Chinese case is that it allows you to broaden out and ask questions of other non-Western scripts. For example, in, I forget which Adobe application. So Adobe, the Adobe company, one of the most important design and so forth page application programs. There are Adobe programs where if you copy and paste Arabic, the Arabic breaks. In the year 2024, to copy and paste one of the most widely globally used writing systems on the planet doesn't work. And that's because the depth of the structural privileging of the Latin alphabet still exists and still runs very, very, very deep in the sort of sub basements of the logic of the computational age. That's one reason that it's valuable to understand this case. In the case of this, the second question of English, that's a good place to close. I gave a lecture on the global history of information technology at People's University in Beijing, so Renmin Daxue. And a student came up to me and said, Professor Mullaney, does English have input? Like, is there a shurufa for English? And my answer then, as now, is, oh yes, there have been many, many ideas of how you could have an alternative form of human-computer interaction. English, it's just that no one ever uses it, except for very few eccentric early adopters. And the reason is not because it's a technical challenge. This is very old tech. We've been doing, it's not hard technology to build. It's because of the technological culture of the West has been, in effect, reading its own press, to use an English language, but it basically has become so complacent and believes in the supremacy, deep-seated belief in the supremacy of what you type is what you get, A equals A, B equals B. What could be simpler than that? When I describe shurufa to an average English-speaking computer user, their first reaction is, my heavens, that sounds so cumbersome. Why would anyone do that? It's almost as if they feel bad for a Chinese computer user as to having to use that. I can say, well, you can feel that way, but just so you know, the top speeds in Chinese input are faster than the top speeds in English typing. But it's very hard to wrap one's mind around that. And I'll give you a very, very basic point, and this will be my last share, I promise. But hypography, this idea of what you type is not what you get, was in fact not invented in China. It was simply augmented to a great extent. Probably the first, I would say, serious system with regard to hypography can be found in courtrooms across the Western world in the form of what we think of as the stenograph typewriter. So the reason that a court stenographer is able to keep up with the speed of speech, objection overruled, you're in contempt, etc., is because they're not using a QWERTY standard keyboard. They're using this special device that produces a transcript like the one you see, which is complete gibberish. It's impossible to understand what this is, because what they're producing is a code that then the person has to translate from the primary transcript into the secondary transcript, which again sounds very cumbersome, except when you realize that when you transcribe text this way, a court stenographer can record at much, much faster than the speed of human speech because of this mediated environment. If you gave someone a computer laptop or a Remington, they would never be able to keep up with the speed of human speech. This is itself a form of hypography, just like we see today in Chinese computer users. You produce a primary transcript that is ephemeral. It is meant to be disposed as soon as it produces the secondary transcript of English in this case, or of Chinese. But the key of it here is quite simple. In the Western world, only court stenographers know how to use a device like that. In Chinese computing, effectively every man, woman, and child is a court stenographer. Everyone is trained to think in this separated state where input and output are different. But there's an advantage. There's an advantage in that difference. And so, yes, one could imagine rebuilding English language input. The only problem is probably no Anglophone computer user would ever, or Italian-speaking computer user would ever buy your product, because they still believe in their heart of hearts in the supremacy of the system they already have.
Thank you.
Thank you. Grazie.
Thank you, Thomas. It's been a fascinating discussion, and I think that you've broadened our horizons within the idea of technology and humanity, which is the key idea of Biennale Tecnologia. Looking forward to have you in Italy to watch live posters of Olivetti and Macchine per scrivere and other stuff with us.
I would love that. And mi dispiace tantissimo ancora, and thank you all so much.
Grazie.